very small. It's only about a half an inch across. It weighs about a half a gram. It's located on the ventral surface of the brain within the skull. So do you remember last semester when we dissected the brain? Do you remember that? And I said the little hole right below the optic chiasm was called the infundibula. And if the pituitary gland was still there, that's where it would hang from, the infundibula. You want to know that the master gland is made up of two separate glands. We have the adenohypophysis, which is the anterior pituitary gland. And you can remember that because A in adenohypophysis starts with an A, and of course so does anterior. So the adenohypophysis is the anterior or the front pituitary gland, and the neurohypophysis is the posterior pituitary gland. Okay, so don't confuse those two. Here, just to refresh your memory, here's that infundibulum that I was talking about, and there's the pituitary gland. Has Dr. Kimball talked to you about stains? Okay, then this is probably old news, but I want you to know the three types of cells that can be identified according to their affinity for certain stains. This is really easy. Chromophobes do not stain because they're afraid of color. Okay, so there's no stain at all. Eosinophils stain with acid stains, so we think of them as acid stain lovers. Basophils stain with basic stains, so we think of them as base stain lovers. Okay, so please remember those. I want you to know that we have 5 functional types of secretory cells. 5 functional types of secretory cells. We have somatotrophs, corticotrophs, thyrotrophs. What do you think of? Yeah, the thyroid, lactotrophs, and gonadotrophs. On slide 6, I want you to know what each one secretes. So somatotrophs secrete the growth hormone. That's easy. Because what's the growth hormone's name? Somatotrophin. So somatotrophs secrete the growth hormone. Growth hormone's name is somatotrophin. So that's easy to remember. Corticotrophs secrete a hormone called ATCH. You want to know these abbreviations. ATCH, which is adrenocorticotropic hormone. Adrenocorticotropic hormone. That's why we have the abbreviation, ATCH. Thyrotrophs, you told me you think of thyroid gland, and you would be correct because it secretes TSH, which stands for the thyroid stimulating hormone. Thyroid stimulating hormone. Again, you want to know these abbreviations because when you get to core, they may just put the abbreviation. They may not put the actual name. Lactotrophs secrete prolactin. Lactotrophs secrete prolactin. Do you remember what prolactin does? What it's responsible for? It's okay. We'll talk about it. It is lactation. LH, which is luteinizing hormone, and FSH, which is follicle stimulating hormone. That is the extent for the gonadotropes for right now that I want you to know. Because remember, I'm not going into the male and female reproductive here. So you just have to know this. Gonadotropes secrete LH and FSH. So we're going to continue with the growth hormone. What do you already know about the growth hormone from before the break? What's its name? Somatotropin. When do we see an increase? If a patient is suffering from? Yes, or acromegaly, right? You're going to see that increase in somatotropin. If your patient has acromegaly, what's their glucose levels going to be like? They're going to be really high. Now we're going to see why. So the growth hormone promotes growth of bone, muscle, and other tissues by accelerating amino acid transport into the cells. It stimulates fat metabolism by mobilizing lipids from storage in adipose cells and speeding up catabolism of lipids after they have entered another cell. So the reason why the growth hormone plays a role in glucose is right here. The growth hormone tends to shift cell chemistry away from breaking down glucose catabolism. So instead of the growth hormone concentrating on breaking down glucose, it instead breaks down lipids, and it uses the lipids as an energy source. So this leads to increased blood glucose levels. Now, it's all fine, because this is normal physiology. This is fine unless we have too much of the growth hormone. Then what's happening is that you're going to have all this breakdown of the lipids, and it's not breaking any of the glucose down. So what's going to happen to the glucose? It increases. So every time, like someone with acromegaly goes in for a glucose test, it's going to be high. Okay, every time. So you want to think the growth hormone functions as an insulin antagonist. So we all know that insulin will bring down glucose levels. The growth hormone does just the opposite. So it's antagonist effect. The growth hormone is an antagonist to the insulin. All you have to remember there is that the growth hormone focuses on breaking down lipids or lipid catabolism, instead of focusing on glucose catabolism. Now, if it just focused on glucose catabolism and someone had acromegaly, what would their growth hormone be like? Yeah, it would be really low, right? Then they would be suffering from hypoglycemia all the time. So the opposite. So you already know growth hormone is known as somatotropin. Growth hormone is vital to maintaining homeostasis of blood glucose levels. Highlight that really big in your notes. Growth hormone affects metabolism in these ways. It's going to promote protein anabolism, so it's going to build up so that we can have growth and tissue repair. It's going to promote lipid mobilization and catabolism. It indirectly inhibits glucose metabolism because it doesn't break it down. That's what it means by indirectly. So it indirectly inhibits glucose metabolism because it doesn't break it down. Its focus is on breaking down lipids. And it indirectly increases blood glucose levels. Any questions on this? We will be tested on that, so make sure you know this really well. That's everything you need to know about the growth hormone. Okay, so we're still talking about the anterior pituitary. During pregnancy, prolactin promotes the development of breasts. You want to know that. Anticipating milk secretion after the baby is born, prolactin or PRL stimulates the mother's mammary glands to produce milk. And that's your key word there, my nurses, is stimulates. You want to circle or highlight stimulates. Because I don't want you to confuse prolactin with, what's the other one involved in lactation? Oxytocin. Oxytocin is responsible for the ejection of the milk. Okay, so prolactin stimulates the mammary glands to produce the milk. But it's the oxytocin that actually is responsible for ejecting the milk. Okay, so oxytocin equals ejection of the milk.
So what causes the milk to keep producing even when you're not lactating as well?
Same thing, it's the hormone.
Is it the prolactin or the oxytocin?
It's both, because the prolactin is still it's still going to stimulate, and the oxytocin is going to cause the ejection.
So they're synergists, is that
Mhm.
example of synergists?
Of to each other, yes. They basically, they're both involved in lactation, which is a positive feedback loop. It's a positive feedback. Sometimes just hearing another baby cry will cause the mom to eject. Okay, I think what we'll do is, let me finish tropic hormones, and then that'll bring us into the reproductive part that you don't have to know. And we'll be in really good shape, okay? So let's do tropic hormones. So the thyroid stimulating hormone, or TSH, promotes and maintains the growth and development of the thyroid. So when your patient comes in to have a thyroid panel done, they're going to check the TSH, and they're also going to check the T3, T4 levels, which we'll talk about in a minute. Okay, T3 and T4. Causes the thyroid gland to secrete the thyroid stimulating hormone. ACTH promotes and maintains the normal growth and development of the cortex of the adrenal glands. Do you remember I showed you a picture of the adrenal glands and how they sit on top of the kidneys? Well, if we took those adrenal glands and we cut them open, the outside part of the adrenal glands will be the cortex. And the middle would be the medullary part of the adrenal glands, okay? Remember, cortex or cortical means outside of the organ. And medullary or medulla means in the middle. So right now, this ACTH is going to promote the development of the outside part of the adrenal glands. And you're gonna see that the cortex will actually secrete certain hormones, and the medulla will secrete certain hormones. And we'll see that in a minute. So it stimulates the adrenal cortex to secrete some of its hormones. ACTH, you wanna know that. Know the definition of ACTH, what it does. Tropic hormones are hormones that have a stimulating effect on the endocrine. 4 principal tropic hormones are produced and secreted by the basophils of the pars anterior. So we have TSH, ACTH, follicle stimulating hormone, and luteinizing hormone. You want to know that TSH is also known as thyroid hormone, because in core they may just say thyroid, and I want you to know it's the thyroid stimulating hormone. It's the same thing. Here, you don't have to worry about. You don't have to worry about FSH or LH right now. Okay, just, I'm gonna put an X through slide number 12. And 13. That'll bring us to, now we're going to start talking about the posterior pituitary. Up until now, it was all anterior. This is going to be posterior. And let me see. Oh yeah, we should be able to. So if I need maybe an extra 15 minutes, can everyone stay to finish this? Is it good? Okay, I may not need it. But let's stop here and we'll pick up with the posterior pituitary gland and what it does. Okay, we'll do that